I'm Sam Hagerman. I'm president of the Passive House Alliance, and this is a section that features Torsten Clubb, David Peabody, Dan Foley, and Graham Wright. Sorry. Wouldn't be the first time I did that, right?
I use it to my advantage.
I can see that working. We're going to talk about various and sundry issues here. What's the title of this segment? What do you know?
Climate
design.
There we go. Climate design. That's what we're talking about.
Where are we?
First of all, I wanted to mention tonight, after all our shindig is over, there's my organization, along with Mark Miller, our interim executive director back there, hosting drinks and hors d'oeuvres at the sidebar. There's a little sign back there that has all the information about it. And then after this session is over, there's an AIA continuing education credit sheet that I have at my table. Just drop by and sign it. And with no further ado, I'd like to introduce Torsten Clubb with the Cold Climate Housing Research Center. And Torsten is master builder and innovator in our field, and someone to watch closely. Emphasizes empirical results and data and groundbreaking leadership in low-use energy design. Torsten.
Thanks much. I'm surprised that there are so many people in here who are looking for cold climates. It feels like summer to me outside. Thanks for the kind words, Sam. I'm here to talk about building passive houses under the extremes conditions. You know, far up north, I live in Fairbanks, Alaska. I have 14,000 heating degree days. I deal with 50 below temperatures for 2 months out of the year. So it's, like Mark put it kindly earlier, uninhabitable space. You know, why people live there is questionable. Why do I live there? I could live anywhere in the world. It's a personal choice. I love it there. I'm originally from Germany, and I have lived anywhere from Africa to New Zealand. I have been all over the world. I have guided all over this world, and I love it up there for certain reasons. And I started specializing in building high-efficient buildings about, I would say, 7 years ago. And since then, I've been picking away on how can we make this work in our climate. And I built this house last year, finished it in January. This is my third attempt on a zero-energy home in Alaska. It's my personal home. Hopefully, I'm not going to be commented on my blue color like the poor other house we just seen a while back. You know, colors, personal choice. Solar panels, they don't look pretty either, but they're very functional. I have ugly things sticking out the front, which I call thermal shutters. It's a very functional house. I have not heated this house actively since February 5th. So I'm over 8 months right now on 100% solar for all of my heating and domestic hot water, which doesn't mean a whole lot here, but it means a whole lot in Fairbanks. You know, I've sat in my living room at 24 below outside temperatures at 70 degrees comfortable without heating. That is, to me, very functional. So my background really is this. I'm an avid climber, and I've guided all over the world. I've climbed a lot of big mountains, and there's one thing I really learned: climate matters and location matters. There's nothing else I need to say. We can't just assume that Fairbanks is Frankfurt. It doesn't work. Things which work in Germany do not work in my climate. That's just a fact. And we can't pound a round peg into a square hole. And if we're going, who is familiar with PHPP in this room? Hands? Okay, most of you. If you take the standard US example house from Katrin, and you take Yellowknife, which is very similar to my climate, and you change the climate data, this is what you're going to get. Wow. What does this really mean? It means somehow I have to reduce my load by over 4 times. Now I challenge everybody in this room to try to take, because you can do this in your PHPP, you take that house in that climate and you make it a passive house. It's impossible. It's absolutely impossible. No matter how much insulation, no matter what windows you put on, it doesn't work. And Graham, can you run this for me in PHPP, please? How do we do this? You know, how do we deal with a climate where for 2 months out of the year I have more northern lights than I have sunlight, and I have extreme cold temperatures? How do we make shelters work in this climate? So I'm very, very lucky, and I found the person who had all the answers for me. And I'd like to introduce you, my friend, who lived there for 2,000 years, very sustainably, and who knows a few basic things about building in cold climates. And I think that he knows much more about it than some building scientists in Germany. So it's about what? It's about heating. For us up in the north in cold climates, it's all about heating. That's just a short matter of the fact. And if we turn off the heat, what will happen? Yeah, we freeze to death. Do we have a choice? Do we have the choice? No, we don't. We have to heat. We can't build buildings efficient enough not to have to heat. It's impossible. My soil temperature is 32 degrees. How much preheating am I going to do with that? Am I going to heat my house with that? No, I can't. So a code-approved house, a high-efficient house which gets an energy credit in my town built at these standards of today, if I turn off the heat in that house for 4 hours, I'm at freezing temperatures. Is that acceptable? No, it's completely inappropriate shelters for the climate. But in the end, it's all about heating, and again, people lived here for a long, long time with appropriate lifestyles, and in the end, it was the people who made it work. So there's two things I think we really need to look at. It's about heating, and it's about people. We can't just design buildings with not thinking about people and climate. And we have a problem nowadays. None of us wants to sit around in fur coats and down parkas all day long because it's too cold in the building. So we create the Arctic is on the outside. On the inside, we have the jungle. We have 70 degrees, humidity levels. That's what we think is comfortable. We want to sit in shorts and t-shirts inside and look outside in our very cold environment. So some key lessons. First of all, we need to understand the very basics of physics and nature. All of our building systems for the northern climates, in my opinion, most of them don't function. They can't, because they define nature. And we have to understand that BS is not necessarily BS, but building science. And a lot of people don't really like to study up on it, but it's extremely important to understand how buildings function if we want to build shelters which really work in our climates. And for us in the north, we can't just take anything for granted. We have to come up with new solutions. We have to think outside the box, because otherwise it just doesn't function. And to me, absolutely the key, we have to start loving the sun. I will never ever look at the sun the same way since I live in a house which is completely heated by the sun. If I wake up in the morning like this morning and the sun shines in the window, I have a smile on my face because I know right now my house would be charging up energy. And there's one of the problems, I think, with our solar industry. And that is not because solar doesn't work, because it does, but it's because of this guy. In our society, we need to make money. If we put up a solar system which just functions by itself, who is to make money of that? I'm much better off installing a boiler, which I need to take out after 10 years because it doesn't work anymore. Then I have every year maintenance I can do. I can sell fuel. much better for our economy. Here I just put up solar panels and I'm all taken care of. There's nothing to do. So what are some basics? I thought long and hard about, what is really the key principles, and it's dead on basic stuff, which I just don't see happening oftentimes. We need to start out with the site. We can't just want to build an efficient building. I mean, take this building right here. There's about everything wrong about it as far as efficiency goes, because people just don't pay attention anymore to where things should be and how it's oriented. Then we need to look at design. This is my first attempt on a zero energy house. This is a off-grid home basically, which is outside of Fairbanks, which is completely powered by wind, solar, and a large 12,000 gallon annual heat storage tank. He burns about 2 cords of wood in the wintertime. It's functioning really well. Size. Why do we penalize small houses? It's the first thing for me, which I do with every client. I try to chop that house down. Smaller houses consume less energy. That's just a fact. And then shape, of course, makes a huge difference. If I have architecturally very intelligent structure, it's very inefficient. In our climate, can we afford that? No, we can't. I'm sorry. Looking at octagons, looking at round buildings, things where shape helps us reduce loads makes sense. And then orientation, we gotta really work with the sun. If we are not, then there's no way we are able to get where we need to be. Lots of south-facing windows, lots of thermal mass inside so we can absorb any energy. I always like to use rock work on the big windows to absorb more heat. And to me, there's only one secret really, and it's about windows. I don't think really a whole lot has changed since the 70s on that. We always fight windows. And we cannot build technically good enough windows for extreme cold climates. Technology is not there. We would need a much better window than what we can actually feasibly build. I've experimented with 5-6 panes of glass. We can get the R value where we want to be, but then we are losing the solar heat gain coefficient. We're shooting ourselves in the knee. So this number really is all what it comes down to, for me at least, in PHPP. I want to be able to get more here than here, which I can do in my climate only with what? With properly orientated windows. They need to be really dialed in for passive solar gain. I need to have the ability to absorb that heat. I need thermal mass, lots of it. Over the years, I've increased the mass on my buildings on the inside dramatically, and it works really, really well for me. Insulated mass. And then, of course, I gotta be able to somehow keep this heat inside. So if we have a lot of clear glass, we have a lot of loss at night, so we need to cut it out with thermal shutters. We need to close these holes. And then in my climate, it's pretty much impossible to make north windows work. Sometimes, of course, we have to, but if I can avoid it, I always leave north windows completely out. Use transom windows to daylight. And then I've fought many arguments about this. The position of the window, to me, is a complete no-brainer. And it completely blows me away why people are still arguing about this. It's 20% increase in efficiency, measured, real world. This is not just some calculation. It works just like a fur parka does. It works. It works very, very well. And in our climate, the windows is what's killing us. Why would we choose to put it on the outside? For what reason? There is no reason at all. We need to over-insulate both sides. We need to place this 50% in the wall. And everything else is stupid. I mean, that's the short of it. The argument that it looks better, it's easier to detail, I really just don't believe that we can afford giving away 20% for free just because it looks better. Either we're trying to build high efficient buildings or we're not. That's just my opinion about it, and this is really a fact. It works so well. You can't give it up. And my little girl here shows us quite how deep my walls are. They're 24 inches thick. So this is really 50% in the wall. It's not on the inside. There's just as much space on the other side. On the bottom, basically, we slope these silts at 10 degrees so water can get out, and then we over-insulate both sides on inside and outside. Here you kind of see the full size of this. This is actually a wall. Fairbanks, Alaska is cold, so we need lots of insulation. And we need thermal shutters. Anywhere in the north, who is building a passive house in the north here? Hands. One person? Only one person? Jesus. Well, cold. Everybody who considers building something in a cold climate, raise your hand, please. One? Yeah, they're much better. Well, no,
In the mountains.
no.
It's cold up there.
I mean, what is the hard problem in PHPP? To make things work. You're at a point where you're like, this is impossible. Have you been at that point trying to make things work? It's really, thermal shutters is the only solution. If you're anywhere where it's really cold, right now there is no other answer. If you want to reach this standard, you have to use thermal shutters, which is a problem because thermal shutters, first of all, there's nothing on the market. There's not one product on the market right now which functions, and they are expensive. So if we are to certify buildings in the north like this, we're really penalizing people if they want to go through this. That's one of the reasons why Scandinavia, they have 3 different numbers for their climate zones. At my climate, the number which you can reach without thermal shutters stops at about 9.2. That's it. There's no other way. No matter what you do, you can't get below that. And that's basically what they've done in Norway, Sweden, and Finland. And I think that's very valid. Nevertheless, for our climate, where I am, really cold, it makes really sense to put thermal shutters on, even if it's expensive. I have an R75 wall, and I have an R7 window. This makes no sense. Why go through the extreme of insulation if we are leaving all of these holes? And we need windows. Windows are the key. And I pretty much on all of our high efficient buildings now, we use thermal shutters. And then we can't afford any thermal bridges. Anybody in here loves therm? Mark, you love it? Right. Anybody has problems with thermal bridges, trying to get a handle on them? I invite you to come to Fairbanks, Alaska at 50 below, and I give you a piece of metal. You learn all there is to know about a thermal bridge. I'm very, very fortunate that I live in a climate where I can do really stupid stuff, and I do that all the time, and I know instantly the next year I will never do that again. You know, it takes 10 years in a normal climate to figure these things out. It takes me 1 winter. It's beautiful. It's like instant feedback. So no thermal bridges. When we do our slabs, you know, we basically form out the door openings, any door openings, garage openings. They need to be completely thermally isolated. We can't afford anything which would allow heat transfer. Metal is absolutely deadly. That's the only missing link I have, doorknobs, which, you know, have a solid piece of metal through it. I'm desperately looking for somebody who builds me one out of graphite. Somebody has one, I need one. And for us, really, the only solution right now is 2 doors. And then a huge thermal bridge, which we are fighting in code, like in a lot of the municipalities, is the use of air admittance valves. It's insane to use a plumbing stack in my climate, but it's really required. And I'm fighting this with many of the communities we're working in. And then, you know, we have to place the insulation where it belongs. In a cold climate, we need to put the jacket on the outside. That's just a simple matter of the fact. Out insulation was already figured out in 1954 by the Canadian government. They already back then figured exactly all of the right answers for cold climates out a long, long time ago, but we're still struggling with it nowadays. So this is a shot on my new wall system, which I call the Arctic wall. Nice term for really just saying it's a remote or a persist wall, basically a double wall, which is filled with dense packed cellulose. The pressure boundary is basically on the inside, that's the structure, and then it's blown out with dense packed cellulose. I'm going to talk in my next talk, anybody is interested, much more about this and actual measured results. And any building we built right now has on average about 12 tons of insulation in. So it's really simple for me to order insulation. I just order one of these 40-foot vans. There's 980 bags in there, and usually it works out pretty well. The first time I've done that, I was like, holy shit. Now it's like just everyday business as usual. So they're, you know, blown. We started doing this in-house because we couldn't find anybody doing a good job doing it. So we're blowing these walls out. We used to build with exterior insulation, basically with remote or persist. I've stopped doing this this year, basically, strictly out of sustainability factors. This works very, very well. This wall can't fail, but it's 100% petrol-based. So if we built very efficient homes, we have to ventilate them. There's no way around that. And in our climate, if we want to have an efficient building, we need to pre-warm. If it's only 32, 40 degrees, beats a hell out of 50 below. And that completely makes sense. It's very cheap to do a small pre-warm loop going to a air-to glycol-based heat exchanger on a high-efficient pump. Works wonders. It's simple, it's inefficient, it's very efficient, and it's really an absolutely must in cold climates, in my opinion. And then another thing I really started to do over the last years, even more now, we use a lot of indoor plants, built-in planters, hydrocultures. For what reason? What's the key problem of very cold climates?
Dry air.
40 below has nothing in it. It's like a desert. You cannot have moisture in 40 below air. If you take a hot cup of water at 50 below and you throw it in the air, it makes poof and it's gone. So it's very, very dry, and we cannot create healthy climates within buildings with that cold air we're bringing in. It's impossible. What's a healthy indoor climate? 30? 30? Somebody else? 40? For people. We're talking people. We're building houses for people. So right. I personally think anything under 35% becomes unhealthy. In our climate, it means 20%. If we don't do anything, we have 20% within the building. And there's no way around it other than actually actively utilizing plants, indoor plants. I use hydrocultures because we don't have problems with mold, with whatever else. But we completely automate them. We use living walls or whatever else. And they do two things. They humidify the air, and then there's a whole science about this on what to use for taking out volatiles, taking out all of the bad stuff we have in buildings. So again, let's keep in mind we're building buildings for people, not for buildings. It's about us. And we need to breathe, and we need to have a healthy environment. That's, to me, the first thing. So that's really something I can highly recommend if you're in a cold climate. Look into that. Works wonders. And there's no question building something highly efficient in a cold climate is very difficult. And we need to come up with new strategies. There is very little real research which has been done, and there is not one solution which fits us all. All of the remote projects we do through the research center, through all of these remote villages in Alaska, there's not one which is the same, because we go in, we talk to the people, we have design charrettes where people tell us about their lifestyle, and then we come up with designs which work for these people, but all of them are different. But first and foremost, they're about the people, about their life. And it's really like climbing a mountain. When you're on the bottom, it seems impossible that you get up. But once you're at the top, it's like, oh yeah, this wasn't so difficult. And then what do? You already see the next one. I want to climb that. And it's really the same thing. I guarantee you, if you're in a cold climate and you build a building like that, you're not going to go back. It's, for me, impossible to think building a regular house anymore. Why would I? It's stupid. But it takes real effort. It is nothing easy, and we have to come up with a lot of solutions, and we have to do a lot of dedicated research to come up with better answers. But this is really my key message to anybody. We have either an opportunity in a new building, or we have a liability, because we will go back to all of the inefficient houses we built today, and I would say it's about 99% of all of them. We will go back in 5 years or in 10 years and try to fix them, because we missed our opportunity. And that is something to remember. It's our one-time shot right now, and whatever we do, we need to look at the opportunity. And it's not an easy task, but I think it's very important, because we really only have this planet right now, and we should better take care of it. Questions? Yep. You know, overheating to me is very simply taken care of in a building by passive means. Thermal mass, I create thermal mass within the building to absorb, and I can night flush in my climate. It's very simple. And besides that, I use, like on these big windows, I use an evaporation pond, which really cools this to a level where I don't have any overheating problems. It's a completely passive technology to basically just create a sheen of vapor in front of the big windows to block out solar radiation. But you know, then again too, my climate, I have the sun up here in the summer. In the wintertime, when I need it the most, it's right down here, and it shines right into the building, which is very, you know, positive for our climate. It's not a problem at all. No, it's very comfortable. Overheating, I don't have issues with overheating. You know, it's, if the building is designed right, it can completely handle it. Yep.
Do you have a sense of the efficiency difference between passive solar gains through windows and solar thermal?
Yeah, I have some slides on that on the next one too, where we have measured data out of this building basically, which shows us how much are we actually passively getting and not. But really with the proper amount of mass, and I'm talking a lot of mass, my building has 180 tons of thermal mass. I'm going to build a big commercial building that has 10,000 tons of mass built into it, insulated mass. I'm really a big believer in thermal mass in our climate now. Yep.
What would your typical thermal mass look like in your home? Is it concrete floor?
It's, yeah, basically it's stained concrete. I use stained concrete. We do artwork on the concrete. And then I use usually a 4-inch slab, and then I utilize either compacted gravel or sand basically under that. Concrete is too expensive to use.
I got a couple other questions. How many heating degree days?
14,000.
And what are you using for your, I guess you were doing a geothermal air loop system?
It's just a very small loop, which just pre-warms the incoming.
Is that PVC material?
Yep, it's 3/4-inch PEX off the shelf, Home Depot. Yeah. You know, I mean, to me, this is the #1 rule. If you know, I can build a house which functions anywhere. You know, we built a passive house in the Antarctic. We can do anything with money. What we cannot do is sell a product and help people. I want to be a solution. I want to be able to write out a list of parts. Give this to Graham. Graham can go down to Home Depot and buy it and build a house and make it work. That's really ultimately what we need to do. And you know, I don't think that we can't, because all of the stuff in my house is really, there's no real technology there. It's all really basic stuff. You know, it's about storing heat, annual heat storage, which I haven't even touched on because we could sit here for 3 days talking about it. And I think it's very important, but you know, we just don't have the time. And that's to me really the answer for our climate. That's how I'm able to get most of these buildings to almost zero energy. I mean, I produce all of my heat for domestic hot water and heating with 48 watts of energy. How cool is that?
Pretty warm.
Do you use your thermal shutters nightly?
Yep. Sun goes down, it starts cooling down, we close them.
I say, and is it important that they seal real well, or are they?
Yeah, thermal shutters are difficult to do. They need to be on the outside. I've tried very hard to make inside shutters work, but it's impossible to seal them properly. Why would we want them on the inside? Because it's so much easier. Closed, done. On the outside, we need to motorize them. But if you have inset windows, that's one of the surprising things I found. With the windows inset as they are, thermal shutters work a lot better and are a lot easier to deal with these convectional loops you otherwise have. And they work wonders. I have like that big shutter in front of my huge window. It's an R40 shutter. I close this thing up, man, it's a day and night difference.
Are these gasketed? Do they snug up to the wall?
It's just not. I mean, that thing is about 1,000 pounds, so it's like really heavy. But no, I mean, I'm really surprised. With the inset windows, air sealing is not a huge problem. However, on the outside, we need to motorize them somehow. You know, that's systems which are not on the market yet. Yep.
Winter solstice, how open is your house? I mean, is your thermal shutter closing off those windows 20 hours a day?
Oh no, I mean, the sun comes up, daylight comes up, we open it. You know, that's for sure. Yeah. Not just, you know, I mean, it would probably sometimes be better to leave them closed, but it's people, you know. You don't want to be in a house like that. You don't.
But his comment during the winter solstice, you don't have any sun, do you?
We have 4 hours of daylight in the winter.
On December 21st, you'll get 4 hours?
4 hours. Yeah. So yeah, I'm lucky. I have sun.
How close to the Arctic Circle are you?
About 200 miles.
So that would be 70 latitude maybe?
64.
No, the Arctic Circle.
The Arctic Circle. No, I think it's 68. Yeah.
You mentioned that you're not doing the remote wall system which you developed earlier. Can you say more about your current wall system?
Next talk. My next talk is all about that. So.
You mentioned briefly about a 12,000-gallon storage tank, and then I think subsequently you said you didn't want to talk about that. Is there a Cliff Notes version you want to explain?
No, it's just time. We don't have time. You know, we have 30 minutes to talk about what's important in cold climates. It's one piece which I think is very important if we're really looking at becoming to zero. If we're not looking at becoming at zero, if you're just trying to build a high efficient building, these things will get you there. But I think that with annual heat storage, you know, we can get so much further. And I'm a big believer in it. But,
On the
Absolutely. Yeah, and there's a ton of people. Yeah, there's a ton of people who tell me today still it's impossible, it doesn't work. And one of my main goals is right now to get this building online with all of the sensors. We have sensors throughout the whole building so that anybody in this room can go on, they can see what this thing is doing. Because what I say or what I tell you guys doesn't mean shit. Matters is what is this building actually doing. And that's what I really want to see, have people see.
What has changed in 20, 30 years?
Nothing has changed at all. It's really nothing has changed other than I'm probably, because of my German nature, I'm very hard-headed, and I spend a lot of time, money, and energy trying to come up with an idea on how this actually can work properly. And you know, there's other systems in Europe which work too very well. Sonnenhaus, if you Google that, there's a lot of projects. You know, there's about 100 buildings in Europe now. However, they are in Europe. They are in a climate which is very different, and they're very expensive. You can buy a tank like that for $40,000. Whew. Try to sell that to somebody.
So part of the reason it's working for you is that in other climates, there are less expensive ways to get to your goal.
No,
And your climate's accessible.
it just works because I chipped away on it. The first system I built, it worked. But now I'm like, oh my God, what did I do? You know, it's really about coming up with solutions, and all of it will be published. I'm writing a report on it. I don't get a patent on it. I want to have everybody the ability to buy these parts and pieces, and you can buy them off the shelf in any plumbing store to build similar buildings, because they work, and they work very, very well. And it's a solution, in my opinion. I think we're out of time. So, I mean, I'm around the conference. Find me if you have more questions. Thanks so much.
Thanks, Torsten. Torsten reminds me of the guy who builds the space shuttle so the rest of us can build better bicycles. And also, it makes me glad that I don't have to build where he lives.
Right. Yeah, tells you how intelligent I am.